Welcome students. Welcome again to my another new lecture. I am Muhammad Tanvir Ahmed, lecturer, Department of Civil Engineering, World University of Bangladesh. Learning objectives. In this lecture, we will discuss about the following topics. First, we will discuss about groundwater occurrence, then types of aquifers, and the last one is aquifer parameters. Groundwater is the water that is stored below the earth's surface. We know that there exists void space in the soil, and in void space there may some water content which is called groundwater. So we can say a groundwater is that water which exists in the pore spaces and fractures in the rock and sediments beneath the unsaturated zone of soil, which can flow freely into a well, tunnel, spring, etc. In figure we can see this is surface water, this is land surface, and below this land surface the zone is called unsaturated zone. Unsaturated means that there exists little some water in the void space of soil in this layer. And below this unsaturated zone, this is called saturated zone. That means in this layer the void space of soil is totally filled with water, and from this zone water table starts. That means this zone is normally called the water table. And below this zone there may exist hard soil, that rock, gravel, etc., and water can exist in the fractures of rock and also in the void space of gravel. That means the water can exist all and every space from unsaturated zone. Groundwater occurrence. There are many factors which affect the groundwater occurrence, and the most common factors have listed here. First one is porosity. We know porosity is the percentage of free available zone in soil. That means it is the percentage of void space. So if the void space increased, the rate of groundwater occurrence will also be increased. Thus porosity influences the groundwater occurrence. Then saturated and unsaturated zones. If the depth of saturated zone increases, the depth of water table will also increases, and vice versa. Then permeability of soil. We know permeability is the property of soil that allows the passage of water to the interconnecting voids of soil. A soil that allows water to pass through its interconnecting voids is called permeable soil. So if the soil is more permeable, the groundwater occurrence will increase. The last one is aquifer. Aquifer is the layer of soil which contains groundwater and is readily yielded to wells. So all are the factors that influences the groundwater occurrence. Types of geological formations. There are basically four types of geological formations in soil, which are aquifers, aquitard, aquiclute, and aquifuse. Aquifer. An aquifer is a groundwater reservoir which is composed of geological units that are saturated with water and sufficiently permeable, which can yield water in a usable quantity to wells and springs. In another way we can say the soil strata which contains groundwater and will readily yield it to wells are called aquifers. So we can say aquifer is a groundwater storage which can store water. Sand, gravel deposits, sandstone, limestone, and fractured crystalline rocks are examples of geological units that form aquifers. Generally, these units create a larger void space which can hold a good amount of water in its void. Aquifers provide two important functions. First one is to transmit groundwater from areas of recharge to areas of discharge. As we know, aquifer is interconnected reservoir or space in soil, so recharge or discharge of water from any point of this reservoir influences the whole aquifer. Then, to provide a storage medium for usable quantities of groundwater. From the definition we have seen that aquifer is an underground reservoir, so that it will work as an storage medium too. The amount of water a material can hold depends upon its porosity. Types of aquifer. There are two types of aquifer. One is unconfined aquifer and other is confined aquifer. First we will discuss about unconfined aquifer. An unconfined aquifer is one which is not confined by an upper impermeable layer. So we can say this is the topmost layer of water table, and it is also called water table aquifer. Confined aquifer. A confined aquifer is one which is confined under a pressure greater than the atmospheric pressure by an upper impermeable layer. It is also called artesian aquifer. Generally, this is the bottom part or bottom layer of the water table which is confined by an impermeable layer. So there exists a greater pressure above atmospheric pressure. And this is water table, and the topmost layer of this water table is called unconfined aquifer. And this is the impermeable layer, and below this impermeable layer there exists confined aquifer, and the pressure in this confined aquifer is greater than atmospheric pressure because of the position of this impermeable layer at the top of this confining layer. Aquitert. It is a partly permeable geologic formations. As it is partly permeable, so it transmits water at a slow rate. Its rate is so slow that pumping is not possible by well. Also, it is known as a leaky confining layer. Aquiclute. It is an impermeable layer of soil that may absorb water slowly but does not transmit it. As soil is impermeable, so water transmission is not possible in this soil. A body of relatively impermeable rock that is capable of absorbing water slowly but does not transmit it rapidly enough to supply a well or a spring. Or another way we can say, the impervious formations or strata containing very little groundwater are termed as aquiclutes. Aquifers. An aquifers is a geologic formation that does not have interconnected pores. It is neither porous nor impermeable. The example of this kind of materials may be rocks like basalt, granite, and it can neither store water nor transmit from it. This type of material is called aquifers. So simply we can say aquitert is permeable geologic formations. Aquiclute is impermeable geologic formations. Aquifers is neither permeable nor porous. It does not have interconnected pores. An artesian well is simply a well that doesn't require a pump to bring water to the surface. And this is possible due to the heavy confining clay layer which is positioned at the top of this confined or artesian layer. And due to this layer, there exists a heavy pressure, and this pressure forces the water to the surface without any sort of assistance. Here in this figure, we can see that this is an unconfined aquifer, and this is an confined aquifer. Another name of this confined aquifer is called artesian aquifer. There is a clay layer which is positioned at the top of this confined or artesian aquifer. This clay layer or this confined impermeable layer creates a pressure in this confining aquifer or artesian aquifer, which forces the water to come off in this artesian well. This is called artesian well because this well has built up in the artesian or confined aquifer. Any rainfall can research this unconfined or water table aquifer, but due to this upper confining bed, water cannot enter into this confined or artesian aquifer. So the research of artesian aquifer is possible only where there is a end of this confining bed. So we can say research of confined or artesian aquifer is difficult compared to unconfined aquifer. Properties of aquifer. The aquifer has the following properties. First one, porosity, then specific yield, specific retention, coefficient of permeability, transmissibility, specific storage, storage coefficient. We will discuss all these properties one by one. Porosity. Porosity is the percentage of free available space in soil. That means it is the percentage of void space. Simply we can say it is the amount of pore or open space between soil particles. In sediments or sedimentary rocks, the porosity depends on grain size. As we know, the circular grain-sized particles creates a larger amount of porosity. The shape of the grains. If the shape of the grain is triangular, it creates a smaller amount of void or porosity. And the degree of cementation. That means the intermolecular attraction of the particles or body. If the intermolecular attraction or forces is increased, the porosity or void ratio will be decreased. Well-rounded coarse-grained sediments usually have higher porosity than fine-grained sediments because the grains don't fit together well in coarse-grained sediments. But in fine-grained sediments, the void space is filled by the fine amount of the particles. So void ratio in case of fine-grained soil is always smaller than the void ratio in case of coarse-grained soil. Specific yield. Specific yield can be defined as the volume of water released from a unit volume of aquifer materials when allowed to drain freely or by gravity. In another way we can say it is the ratio of the volume of water that drains from groundwater storage due to the attraction of gravity to the total volume of the saturated aquifers. The specific yield depends on soil characteristics. For gravel, it occurs rapidly. For fine sand, it occurs moderately. For clay soil, it occurs slowly. And for solid rocks, no drainage occurs. Specific retention. It is the ratio of the volume of water that cannot be drained out to the total volume of the saturated aquifer. In another way we can say it is the remaining volume of water which cannot be removed by gravity drainage, is held by capillary forces and by other forces of attraction and is called specific retention. The specific retention increases with decreasing grain size. As grain size decreases, the porosity or void will also be decreases. For these regions, the specific retention will also be decreases. Soil having low permeability may not easily drain out. For example, clay has a high porosity but low specific yield, and its permeability is low. Coefficient of permeability. It is the ease with which water can flow in a soil mass or a rock. The coefficient of permeability can be defined as the quantity of water that will flow through a unit cross-sectional area of the aquifer in unit time under a hydraulic gradient of unity at a specific temperature, usually 60 degrees Fahrenheit. Simply we can say the coefficient of permeability is equal to the discharge per unit area of soil mass under a unit hydraulic gradient. It is usually expressed as centimeter per second, meter per second, meter per day, etc. The coefficient of permeability is also called hydraulic conductivity. Transmissibility. It is the discharge rate at which water is transmitted through a unit width of an aquifer under a unit hydraulic gradient. Simply, it is the discharge per unit width of the aquifer material. It is usually expressed as meter cube per day per meter, or simply meter square per second. Specific storage. It is the amount of water per unit volume of a saturated formation that is stored or expelled from storage. In another way, we can say it is the amount of water that can be stored in a unit volume of aquifer materials. Storage coefficient. It is the volume of water released from storage or taken into storage per unit of aquifer storage area per unit change in head. In another way, we can say it is the volume of water released to the original storage volume. It is dimensionless and it ranges from 0.02 to 0.30 in unconfined aquifers. And that is the end of our today's lecture. Thank you everyone.